guys, this is Eli with the RadiArmor, and today I'm going to show you how to test your EMF blocking case. Now there's a lot of fake EMF protection products out there on the market, so we always encourage our customers to test our products. That being said, it's important that you use the right type of EMF reader. The most important thing is that you use an EMF reader that measures high frequency RF radiation. A lot of EMF readers out there only measure low frequency magnetic field, or what's commonly known as LFMs. Now, when you look at all the studies out there that talk about the potential dangers of cell phone use, it's in reference to that high frequency RF radiation. That's the type of radiation that your phone emits when it's communicating with cell phone towers. Now, a lot of people hear high frequency RF and they associate that with low frequency RF, such as AM, FM radio. However, high frequency RF is magnitude stronger than low frequency or regular radio waves. In fact, high frequency RF is much closer to microwave radiation. Part of the new 5G spectrum that's permitted under international guidelines technically falls under the microwave band. So here I have 4 commonly used EMF readers, and I'm going to show you how to test your case and show you what you might expect to see using each type of EMF reader. Okay, I'm just going to jump right in here. This is the NTurk MK08. This EMF reader doesn't measure any high frequency RF, so right off the bat, you wouldn't want to use something like this to test your case. Also, a reader like this can give you some very strange results. For example, here is our latest iPhone 11 case. This is in the teal blue, and you can see there's no phone in here. Okay, and I'm going to go ahead and just turn this on. Okay, and I'm going to go ahead and just go like this. Okay, and now the reason why that's going off is because the magnet that's inside the sensor is reacting to the metallic EMF blocking liner that's inside the case. So there's no EMF that's coming from the case itself. It's all being produced inside the reader. It's sort of similar to how you can create an electric field by running a magnet through copper coils. So again, you would not want to use an EMF reader like this. Okay, next up is the Trifield 100XE. The nice thing about this reader is that it's analog, so you're going to get real-time measurements. Also, the RF setting is not calibrated to be overly sensitive. Typically, the higher the sensitivity, the lower the dynamic range. Your phone emits a lot of RF, so having more dynamic range allows you to see the scale of reduction that you're really getting from using our case. Okay, so I'm going to go ahead and place a call here. And this is the iPhone 11 case again. And I'm still on the iPhone 10, but that's going to still fit okay in here. It's a little bit smaller than the iPhone 11. All right. Okay, you can see it's already going off quite a bit. It's maxing out, and this maxes out at 1 milliwatt per centimeter square. So you can see it's already off the charts. I'm going to go ahead and close this here. And you can see there's a huge reduction there. Now again, our cases provide about a 90% reduction in high frequency RF, and you can see that reflected there. Now the reason why you can't achieve, say, 99% reduction is because you're still going to get some EMF that is bleeding off the top and the sides here. There are many companies that claim that they are reducing EMF by 99%. A lot of times it's just a flat out lie, but other times what they're referring to is the actual material that they're using, not the protection that you're actually getting. If you put a sticker that blocks EMF on the back of your phone, that's certainly not going to offer you any kind of EMF protection.
The only way to protect yourself is to have the EMF blocking material between you and the source. And that's why we only make wallet cases. Okay, next up here is the 10 Mars TM195. This is a very high-end RF reader that's designed to detect very small amounts of high-frequency RF in your environment. Now, the default setting for this is to measure in milliwatts per meter squared. The 100XE that I showed you earlier measures in milliwatts per centimeter squared. A meter squared is 10,000 times larger than a centimeter squared. So in other words, this one here is calibrated to be 10,000 times more sensitive than this one here. So if you're going to use a reader like this, the first thing I recommend is to see if there's a setting to reduce that sensitivity. This device does have a setting for microwatt per centimeter square. Now that's microwatts versus milliwatts. 1 microwatt is 0.001 milliwatts. So in other words, even at the least sensitive setting, this is 1,000 times more sensitive than the 100XE. Nevertheless, let's go ahead and give this one a try here. So I'm going to go ahead, and the call is still on, I believe. Okay, call is still on, and I'm going to go ahead and turn this on. I'll change that to, that's still meter squared. So I'll change that to milliwatts. I'm sorry, this is going to be microwatts per centimeter squared. And I'm going to go ahead and put that up over here. Now this device, actually the range for this is 32 microwatts per centimeter squared. So anything above that, it's not giving you the most accurate reading. But this one here right now is saying it's about 82 microwatts per centimeter squared. Let's go ahead and close that. And you can see there, it's gone down to about 20 microwatts per centimeter square. So again, there's a huge reduction, even with this one, which is 1,000 times more sensitive than the 100XE. This is a tri-field TF2, which is an update to the original 100XE. Like I mentioned before, many of the newer digital EMF readers are calibrated to be very, very sensitive, and this one is no exception. For example, this only has one RF setting that measures in milliwatts per meter squared. Again, that's meter squared. This one here is measures in milliwatts per centimeter squared. So in other words, this one here is calibrated to be 10,000 times more sensitive than the original 100XE. So I'm going to go ahead and show you what you might expect using a reader like this. So I'm going to go ahead and turn this on to the RF mode. And I'm going to go ahead and just open this up here. And you notice here that it's already reached its max peak. If you look up here in the top left-hand corner. Okay, and I'm going to close that. And again, you don't see that much difference. And again, if you look here on the top left-hand corner, it's reaching its max peak. Now, once you exceed the peak sensitivity, these numbers here, they don't mean anything because it's simply taking the average of the portion that can be measured. The max range on the TF2 is 20 milliwatts per meter squared. That translates to 0.002 milliwatts per centimeter squared. This one here, the 100XE, maxes out at 1 milliwatt per centimeter squared. That means that this one has a dynamic range that is 500 times greater than the TF2. So again, your phone emits a lot of RF, so you want greater range, not sensitivity. To give you another analogy, imagine that you have a light detector and it's calibrated to detect even the faintest starlight in the pitch of dark. Now imagine that you use that same device to determine the change in luminosity from putting a book in front of a light bulb. That device is going to be so sensitive that even a 90% reduction is going to max out the detector. And that is essentially what is happening here. Now, if you reduce the RF by, say, 99%, then a reader like this might show you that. And we have used this EMF reader before in some of our demonstration videos. Okay, so for example, here is our EMF blocking laptop pad. Okay, now if I go and put this just over the whole top of this, and I put this EMF reader here, you'll see here, it's still maxing out. Now this pad here has a RF blocking liner that blocks 99% of high frequency RF radiation. Now as I go and I just go further over, you'll see that's down to nearly 0. Again, that's because I'm reducing that RF down to about 99+%. Okay, if I'm less than 99%, it's going to be maxing out this reader. Again, this is the same material that's used in the cases.
Alright guys, I hope that helped provide a better understanding of how our cases work and how to test your case. Again, the most important thing is that you have an EMF reader that measures high frequency RF radiation and one that has a fairly large dynamic range. If you have any questions, you can leave them in the comments section below, or you can email us at www.radiarmor.com.